We're going to begin this lesson with a little activity to kind of connect what we saw in the unit circle, where now sometimes values had positive or negative signs having to do with sine and cosine, and kind of connect that further. So first off, recall from the last lesson that the x-coordinate of a point on the unit circle intersected by an angle in standard position is the cosine of the angle. So to circle the important information, x is cosine. The y-coordinate of a point on the unit circle intersected by an angle in standard position is the sine of the angle. So as a reminder, that is cosine theta sine theta is any point. So if I'm on a point, the x corresponds to cosine and the y corresponds to sine, and this is only on the unit circle because the hypotenuse being 1 lets those fractions reduce to cosine being x and sine being y. So the question becomes, and we're going to start to think about trig in a broader perspective, if trigonometric values only existed for angles that fit in right triangles, the above facts would be impossible. So how could I talk about a point on the unit circle, like for example, the cosine of 300? Like how is 300 degrees fitting in a triangle? And my example here is sine 300. I just started talking, so anyway, reference angles and reference triangles make it possible. So I started to talk about a reference angle at the end of the last video, and we're going to learn more about these today. An angle of any size can be drawn in standard position on the coordinate plane. From that angle, a reference triangle, so that's what I drew when I drew those triangles also in the lesson, can be drawn to the closest x-axis. So this is an important concept here. The following activity investigates the signs of the trigonometric functions for angles in each quadrant, and this is signs, positive or negative. So I did the second quadrant for us. It says the sine of the adjacent side is determined by the sine of x in that quadrant. So if we look at this angle, here is my angle in standard position. So this is not really this little angle, but that's how we're going to draw our triangle. So here's my angle. I go to the closest x-axis, which is here, not over here, right? I draw a little triangle, so this is called my reference triangle. This angle is called my reference angle. Remember, the actual angle is out here, but the green one is my reference angle, the one that fits in a triangle. So when I start to label things, the adjacent side is determined by the sine of x. So this direction, this adjacent side to this angle, is x here, and the second quadrant is a negative value. The opposite side from this angle, so here's my angle, the opposite side is over here. That's determined by the sine of y in that quadrant, so that's a positive sign, right? Y goes up here. And then this is a very important thing that's, a lot of this is figuring it out. This is something you need to memorize. This is the way it works, not having to do with x or y. The hypotenuse is always positive, so this is always a positive no matter where we draw it. These two are determined by x and y. The hypotenuse is always positive. So if I start to go here from this angle, sorry, it's like so drawn in, I'll just do it in black again. If I look at the sine of this angle theta, so we're going to label this theta. I'm just going to erase this so it doesn't look like a blob. So there is my theta. And just a side note, remember how, theta seems kind of weird? X and y are already taken by the coordinates of the point, so theta is kind of like a third value. We don't want to use x and y because that could get confused with the x that's here, right, and the y that's here. So it's a third value. So when I'm looking at this, the sine of theta, opposite over hypotenuse, is a positive number over a positive number. So positive, positive. So when I'm in quadrant 2, sine is a positive number. So this doesn't totally make sense with what we've known before. Let's just think about an angle in the second quadrant. So if I think about an angle of 100 degrees, 100 doesn't even fit in a triangle, right? Not in a right triangle. It could fit in a triangle, but if I already have a 90-degree angle, there's not room for 100. Okay, but if I type the sine of 100 in degree mode on my calculator, I do end up getting a positive number. Contrast that to cosine. If I'm working with the cosine of an angle, I'm doing adjacent, right? This is my adjacent side over hypotenuse. That's a negative over a positive. Negative divided by positive gives me a negative number. So if I type in the cosine of 100, that's going to give me a negative value. Okay, so type that in your calculator, you'll see it's negative. Tangent in the same way, if we do opposite over adjacent, right, opposite over adjacent, that's a positive over a negative. That when divided becomes a negative number, and tangent of 100 degrees should also come out as negative on your calculator as long as you're in degree mode. So what I want you to do, and I'll kind of start you off, is in each of the remaining quadrants, you're going to draw a picture, and you're going to work through. One other thing I should say, though, is if you look here at the cosecant, secant, and cotangent values in the second quadrant, basically they're just flipped fractions of whatever. So sine is positive over positive. That's still positive over positive for cosecant. Cosine is negative over positive, so secant is a positive over a negative if I switch that hypotenuse and adjacent. So if cosine is going to be negative, secant is also going to be negative. And so these we don't necessarily think about in our rules the reciprocals because they just fall in line with their original functions. So over in quadrant 1, here's a first quadrant angle. Okay. If I look at this, hypotenuse is always positive. And in quadrant 1, x and y are also positive, right? Positive forward, positive up. So sine is a positive over a positive number, right? Here's my theta, right? And here's my opposite, adjacent, and hypotenuse, right? So sine opposite over hypotenuse is positive over positive, which is a positive number. Everything, right, there's nothing else to choose from, is positive here. So that equals a positive, and of course everything else will be positive because in quadrant 1, everything is always positive. Moving down the page, I'll just kind of get you started on quadrant 3. So here is my quadrant 3 angle. Okay. No way that is ever going to fit in a triangle, but if we draw a reference triangle, right, with a reference angle here, there's my triangle. Okay. Now thinking about sines, hypotenuse is always positive, right? X goes back, y goes down, so both of those are negative. So when I work through it, kind of thinks, well, quadrant 3 is a pretty negative quadrant. Like I think everything will be negative, but it actually doesn't turn out that way. So when I'm working here, and I do sine, right, here's my angle, opposite, hypotenuse, adjacent. Sine is opposite over hypotenuse, negative over positive, which is a negative number. Cosine is also negative over positive, adjacent over hypotenuse, which is also negative. But then when I move over to tangent, I actually end up with 2 negative signs. Negative over negative, which negative divided by a negative becomes a positive. So for quadrant 3, these just carry down, right? So cosecant and secant would be negative, and cotangent would be positive. Doing quadrant 4, here is this angle in standard position, but we know that we're actually going to be using this angle for our angle, right, our reference angle, and we're going to draw a reference triangle. So looking at this picture, the hypotenuse is always positive, the x is positive, and the y goes down, so that's negative. So why don't you finish the values positive or negative for the quadrant 4, and then I'll put them up. So here are the answers. We see that cosine, because it consists of adjacent, right, here's my angle, adjacent over hypotenuse, basically that's the one that's going to be positive here. Everything else is negative. Just another comment, your angle theta is always going to be the one that's closest to the origin here. So we can see theta, 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 and theta. So it's never like this one out here, and it's obviously not the right angle. When we look through this, I'm just going to circle what's positive. So in quadrant 1, all are positive, everything. In quadrant 2, just sine was positive, right? And in quadrant 3, just tangent was positive, and in quadrant 4, just cosine was positive. So if we think of this as the thing to remember, all sine, so all sine, tangent, cosine. That's really the thing that we're going to take out of this. And on the next page, which you guys can flip over to, we have a little chart to remember this. So this is my 4 quadrants, all positive, just like I just said. So all positive, second quadrant just sine, third quadrant just tangent, and fourth quadrant just cosine. So this gives us ASTC, and a little saying to help you remember that is all students take calculus. Okay, now one thing to note, we don't really think about them, they're kind of in the background, but the reciprocals go along with their functions. So when I say sine is positive, cosecant is also, same thing with tangent and cotangent and cosine and secant. So it says we start the brainwashing early. Hopefully all of you, whether in high school or college, will have an experience with calculus. So I'm going to do the practice problems in the next video. This was kind of like how things work.